previous video, we solved the question on Fourier series over any range. Now here we'll be solving a Fourier sine series. Okay, a Fourier sine series over the range of 0 to 1. Now this also falls under the Fourier series function of over any range. Now we can recall that f of x is equal to a naught over 2 plus summation from n is equals to 1 to infinity of an cos 2 pi nx over L plus bn sine 2 pi nx over L. Now this is the formula we use for Fourier series over any range. However, when we come to half range series of Fourier sine cosine series, let's talk about Fourier half range cosine, okay, which range from 0 less than x less than L. Our f of x is equals to a naught over 2 plus summation of n is equals to 1 to infinity of an cos n pi x over L. And we can notice the differences between the two formulas. This one has 2 in it, however this one just has n. Moving on, we notice that this here bn is equal to 0. And a naught in this case is 2 over L integral of 0 to L f of x dx, and an is equals to 2 over L integral from 0 to L f of x cos n pi x over L dx. Now for half range series for sine function, I'm just saying half range sine function within the range of 0 less than x less than L, we can deduce that f of x is the summation of n is equals to 1 to infinity of bn sine n pi x over L. And bn in this case is integral of 2 over L from 0 to L f of x sine n pi x over L dx. Now from the question we were given that we should evaluate the Fourier series, okay, Fourier sine series, okay. See, we are dealing with sine series for this range and for this function. So we have that f of x is equals to 2x minus 1, and since we are dealing with sine, we'll be considering this formula. Also, the range that we are given is 0 less than x less than 1. Now, if you compare this range to this range, that is 0 less than x less than L, we can see that L is equals to 1. So L is equals to 1. So we want to evaluate Bn. Bn is equals to 2 over L integral from 0 to L f of x sine n pi x over L dx. Now let's also substitute our L is equals to 1 there. So we have 2 over 1 integral of 0 to 1 f of x sine n pi x over 1 dx. So this will give us 2 integral of 0 to 1 f of x sine n pi x dx. and we can further rewrite this to give us n sine n by x, or we leave it the way it was. Now proceeding on, we have to substitute our function of f of x as 2x minus 1. So let's substitute our f of x. So this will give us 2 integral of 0 to 1 2x minus 1 of sine n pi x dx. Now if we open up the bracket, we have this to be 2 integral of 0 to 1 of 2x sine n pi x minus sine n pi x dx. Now we can split this differently according to the law of differentiation and integration to have 2x sine n pi x minus integral of 2 from 0 to 1 sine n pi x dx and dx here. These two can multiply these two and be left with 4 integral of 1 x sine n pi x dx minus 2 integral from 0 to 1 of sine n pi x dx. Now this is Bn. This can be integrated directly. However, this function can be split into two as uv. So u is equals to x and v is equals to sine n pi x. So u prime is equals to 1. v1 is integral of v dx, which is integral of sine n pi x dx, and this is going to give us minus cos n pi x divided by n pi or pi n, and v2 is integral of v1 dx, and that's integral of minus cos n pi x divided by pi n dx, and this is going to give us sine minus sine n pi x over pi n squared. Having solved that, we can also remember that our uv is equals to uv1 minus u prime v2 plus u prime prime v3, and it continues. So we can solve Bn to be equal to 4 when we integrate x sine n pi x. We're going to have u, which is x, multiplied by v1 minus cos n pi x over pi n minus u prime, which is 1, multiplied by v2, which is minus sine n pi x over pi n squared, minus here. I want to integrate this term. We have 2, remember our limit of 0 to 1, back to this term. Integrating sine n by x, we'll be having minus cos n pi x over pi n from 0 to 1. So we can simplify it further, and we have that Bn is equal to 4 minus x cos n pi x over pi n plus sine n pi x over pi n square from 0 to 1, and this can give us plus 2, okay, plus 2 within the range of, should be plus, in the range of cos n pi x over pi n from 0 to 1. Therefore, we can now put our upper limit and lower limit. So putting our upper limit, we have 4 into minus 1 cos n into pi divided by pi n plus sine n into pi n squared minus, and now putting our lower limit of 0 into this, minus 0 cos n of 0 over pi n sine n of 0 over pi n all squared, and then we apply upper limit and lower limit for the second term. That's plus 2 into cos n pi over pi n minus cos n of 0 over pi n. Now with this done, we can say that this is equal to 0 because it contains sine n pi, and this is equal to 0 because it's multiplied by 0. This is equal to 0 because it contains sine n of 0. So we are left with the terms of 1 and this. So Bn is equals to minus 4 cos n pi over pi n plus 2 cos n pi over pi n minus cos n of 0 over pi n. Now we can see that this is familiar. Okay, so we can evaluate values of B1, B2, and even B3 and B4. We can pause the video and evaluate the values, and we can see that B1 is 8 over pi, B2 is minus 4 over 2 pi, B3 is 8 over 3 pi, and B4 is minus 4 over 4 pi. Now, after being able to evaluate B1, B2, B3, and B4, we recall that our f of x for this series is equal to the summation of n is equals to 1 to infinity of Bn sine n pi x over L. Okay, and since our L is equal to 1, therefore the f of x is equals to summation of n equals to 1 to infinity of Bn sine n by x. So therefore, we can say that f of x is equals to b1 sine by x plus b2 sine 2 pi x plus b3 sine 3 pi x plus b4 sine 4 pi x. It continues. Therefore, f of x will be equals to b1, which is 8 over pi sine pi x, plus b2, which is minus 4 over 2 pi sine 2 pi x, plus b3, that's 8 over 3 pi sine 3 pi x, and plus b4, which is minus 4 over 4 pi sine 4 pi x. With this done, we can evaluate our f of x to be equals to 8 over pi sine pi x minus 4 over 2 pi sine 2 pi x plus 8 over 3 pi sine 3 pi x and minus 4 over 4 pi into sine 4 pi x. And this will give us the final answer to the question. So we can see that Fourier series over any range can come in the format of Fourier cosine series and Fourier sine series, and it can also come in the format of half range function. Okay, and it will be very important to understand the formula to be used. And in our final video coming up, we will talk about harmonic analysis, which is a different method of evaluating um, Fourier series with the use of tables.